And I'm Maria.
And we are Team Smart Labs. We built a cornhole railgun to learn about projectile physics and to play against a robot.
Projectile motion is a subject every high school student must learn. It has applications in ballistics, seeing how the distance of a water going from a hose, and various sports. Sometimes students learn these equations and they find them very uninspiring.
Cornhole is a fun backyard game that has recently been growing in popularity. To play, there's two teams that attempt to get the bags on the board or in the hole. Each bag that's on the board is 1 point, and each one that gets in the hole is 3 points. To win, you need to reach 21 points. Cornhole involves projectile motion because you need to calculate how hard to throw it and at what angle to release it.
There have been many computers that can compete with humans in mental games such as chess, Go, or Jeopardy. We thought, what about making a robot that can compete with humans in a physical game? We decided cornhole would be the perfect one. What a fun way to learn trig and projectile motion. We built this cornhole railgun that can do all the projectile calculations to score big in cornhole.
Here we have our 4 bungee cords and a braking system that absorbs the excess kinetic energy from the cart, and the bungee cords wrap around these rollers and through an adapter are connected to a nylon cord so we can accurately measure the amount of stretch. Here we have an over-center trigger mechanism and a release. It's over-center so that it can reliably hold the cart without it slipping off. And here is the spool that wraps the nylon cord, which is connected to a 320:1 ratio gearbox and a motor.
This is our human-machine interface. It uses a Raspberry Pi, a motor controller, and encoders. The software calculates the amount to pull the cords back in order to get the desired launch velocity. All the projectile motion is shown on the screen, as well as the calculations for all the key parameters such as flight time, distance, and max height.
Our cart is locked in place and ready to be loaded. Now I'm going to tension the bungees with the P button.
We can now make fine adjustments with the encoder wheel.
Our cornhole railgun is set to the distance and to the angle that we need it to be, but we can also have it shoot different targets.
Firing in 3, 2, 1.
Wow, nice shot.
To aim the robot, we use simple trick. We know that the length of the shooter is 231 centimeters, so we made the height 231 sine theta.
Calibrating the bungees was not easy. This process involves setting the angles from between 30 and 60 degrees and tensioning it from between 120 to 150 centimeters. Then we measured the shots and calculated the initial velocity needed to make the distance.
Here is our Python code. Here we import the packages, define the colors, define the screen size with the option to display on a larger screen, set our global parameters, calculate the paths for our graphics, make estimates for launch velocity based on the stretch and the stretch needed to obtain the velocity. We process keyboard input, read and process the encoder wheel, set the motor velocity, and update the display. Finally, we draw the graphics.
We think that every physics class should do a project like this. It can help students learn physics in a fun way and teach them in real-life scenarios.
So did you face many challenges in this project?
Yes, we did. For example, when we were launching the cart, the cornhole bag would run into some of the stuff at the top, so we had to put an angle here so that it would clear it. We also had a problem with these brakes moving, so we put in bolts through the middle of the extrusion here so it keeps the brakes from moving.
We didn't realize how much force we were going to have to need, so we used to have 2 bungees, but now we have 4.
So have you guys ever played against the robot?
Yes, we did, and it beat us quite easily, although it's not at the level of a pro.
A pro usually can get spin in, and they can they can block the hole and do special trick shots to increase their chances of winning.
We'll leave you with a video of the robot playing against itself.